Okay, welcome to the test review for exam 4. Hopefully this will be helpful. This should be an easier test than last time. This time we don't need our Excel spreadsheets, but you will want this beauty. This guy is the best thing ever. So the Unit 4 exam formula sheet, then you don't have to use your textbook to get these charts, and it has these nice reminders of what formulas you might need. So we'll be using that. And of course a calculator. Okay, the first problem I'm going to do, and last time I made a big effort to write down the problem number on here, and then I found out that they're actually just randomized, so the problem number is irrelevant. So this is the first problem we're going to do. Sarah is single and earned wages of $23,700. She had $4,500 in itemized deductions from interest on a home mortgage. Using the 2013 marginal tax rate table from 257 in your book, what is her taxable income? Okay, so one thing we're going to look at, I'm going to leave this right here, and we're going to look at this, what taxable income is. This is kind of a cool thing that this has on here. It tells us that we start with, you start with your gross income. Then your adjusted gross income is the income minus the adjustments. And they'll tell you if there's an adjustment. Sarah does not have an adjustment. She does, however, have exemptions and deductions. So she's going to take her adjusted gross income, which in this case is her gross income, and she's going to subtract her deductions and exemptions, and that will give you her taxable income, and that's what they want to know. What's her taxable income? All right, so the first thing we're going to do is we're going to write down her number right here. So it was 20. Oops, I guess I can't leave that up for you to see. I'll just move it over to the side where I can see it. Okay, so she has 23,700. Oh, hold on. There we go. 23,700. That's how much she earned. Then she has 45 in itemized deductions, 4,500. And she also is going to take her her exemption. Okay, so typically we would have this number minus the itemized minus the exemption. However, if you look at the chart, her itemized deductions were 4,500, but actually for a single person filing, the standard deduction is 6,100. So she needs to take the standard deduction because it will give her a bigger deduction. So we're actually going to ignore that 4,500, and we're going to go 23,700 minus 6,100, which is the standard deduction, and then minus the exemption, which it has on there is 3,900 per person. So she'll get that as well. So that is minus 3,900. So I'm going to cross this out. We're not going to use that. And then I just get out my calculator and I say 23,700 minus 6,100 minus 3,900. Whoops. Let me try that again. Clearly I did something wrong. 23,700 minus 6,100 minus 3,900. Okay. 13,700 should be the answer. And it is. Okay, so just be aware of that if they tell you it's itemized, you want to make sure that it actually is a better deal than the standard deduction, which in this case it was not. Okay, next we're going to look at, I had to change my screen because my little drawing tablet was not working on the big screen, so I'm a little cramped for space here, but we'll just make do. Maybe it's better. Sometimes I think I get too much stuff going on. Okay, this one says the following data set represents the number of words in each of the 13 articles of faith. Find the upper quartile of the set, or the third quartile of the set. So let me just show you basically how to do the quartiles. Okay, it's not that hard, but I'm going to write maybe what I'll do is write the subject of each one. Okay, so this is when they want us to find the third quartile, right, or the upper quartile. All right, so it gives us a set of numbers. I'm going to arrange these from lowest to highest. So I got 16, 17. You can't see what the numbers are, but just, I already did it. I wrote them down. 21, 23, 30, 32, 32, 35, 42, running out of space, 48, and 66. Okay, those are my numbers. I'm going to count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's 13. So the first thing I'm going to do is cut this in half. I'm going to find my my median, which is the middle number. So that would be number 7. 1, 2, 3, 4, 5, 6, 7. So 30 is my median. I'm just going to draw a little arrow. That's the number that falls in the middle of this data set. That's the median. Then I'm going to take my remaining numbers and also cut them in half. 1, 2, 3, 4, 5, 6. There's 6, which means that my third quartile, or my upper quartile, is going to fall in between these two numbers. Okay, my lower quartile is also going to fall in between these two numbers. Well, luckily in this case, looks like lover. My lower quartile is just 18 because there's nothing in between those two. But in this case, there is, it's 35 to 42. There's a 7 number span. So I need to find the number that's in between those. So what I'm going to do is I'm going to get my 7 divided by 2, because there's 7 numbers in between those. So what you would normally do really is go like 42 minus 35, that equals 7. Then I take my 7 divided by 2, which is equals 3.5, and I'm going to add this to the bottom number. So I'm going to get 38.5 for my upper quartile, or my third quartile. Okay, so that's it. It's pretty easy, but just start with the median and then the rest of it just falls into place. And remember that if it comes out in the middle, like if I'd had 7 numbers over here, I would just have picked that middle number just like I was able to just pick the median. But when it comes out in between, you've got to split the difference and find the number that's exactly in between those two numbers. Okay, the next one, there was one similar to this one. This is a like where they took their scores to see who had the better scores. So I'm just going to write better score. That's the name of this. And it's Matt and Mike. Okay, so what this tells us, let me click over to that one. Then you can see it. Okay. Matt recently took a very challenging chemistry exam in which he scored 75%. His class mean was 68% with a standard deviation of 8.6. His friend Mike took a similar exam in a different chemistry class and scored 70%. The class mean for his exam was 64% with a standard deviation of 10.3. Okay, with the understanding that both tests measure the same kind of ability, like who actually scored higher in comparison to their classmates. Because sometimes don't you think you're like, man, you scored better because you had an easier teacher. And so you feel kind of ripped off. So we'll see who is actually ripped off in this case. All right. So it tells us to use a standard score and percentile chart on page 390 in your book. Well, that score and percentile chart is right here, yay, in the formula sheet. Okay, so it's going to be a little tricky with this one, I think, because, well, we'll just give it a whirl because I can't. This is going to just keep disappearing. All right, so the first thing I'm going to do is I'm going to find the standard score, or the z-score. Okay, to find the z-score, I'm going to take, so I'll also write here z-score. So you can find it. All right, whoops, there's my emails. Let's hide that. To find the z-score, I'm going to use the data value, So I'll just put the value minus the mean over the standard deviation. That is the z-score formula. We put a little line through that. Okay, so in this case, it told me that Matt's score, I'm just going to write Matt's information down. Matt's score was 75. And the mean in his class, so score, mean, and standard deviation. Okay. So the score was 75, the mean is 68, and the standard deviation was 8.6. Okay, that's for Matt. For Mike, his score was 70. His mean was lower, it was 64, so his teacher didn't teach as well or gave a harder test probably. But we'll see who is actually better in relation to his peers. And then the standard deviation was 10.3. All right, so all I'm going to do is going to take the score, the value, which is going to be 75, minus the mean, which is 68. That's going to be divided by the standard deviation, which is 8.6. I'm going to do the same thing for Mike. Mike is going to be 70, his score, minus the mean, 64, over 10.3. Okay, so get out my calculator. Now I want to show you something kind of important on this. So I'm going to go 75 minus 68. Make sure you push equals before you divide by 8.6. Otherwise, only the 68 will be divided by 8.6. So I get 7 divided by 8.6. And that equals 0.8139. Okay. Then I'm going to do the same thing for Mike. Let me find my calculator again. It's lost. Okay. Calculator. And I get 70 minus 64 divided by, oops, I did what I told you not to do. 70 minus 64 equals divided by 10.3. And I get 0.5825, okay? So now, this is my z-score. Uh-oh, I just turned my volume down somehow. It was magical, but I bet I did this. Okay, that is my z-score. So now I'm going to get the z-score page. And I'm going to look it up. So the first one we're looking up is 0.8139. Okay, so I'm going to find the z-score of 0.81. Now, probably you're not going to find the exact score. That's okay. You just pick the closest thing. So this 0.8 is the equivalent percentage of 78.81. So I'm going to write that down. So he is in this, he'd be like at 78% of his class. He's better than 78% of his class. Then we're looking at his 0.5825. And you can see who's going to be better at this point, but we can see what the actual percentages are. 0.5825 is closer to 0.6, so we're going to go 72.57. So Matt did better in relation to the rest of his peers than Mike did, because that's what that score tells us. Okay. All right. That's that one. That's probably about as complicated as you're going to get in this test. It's really kind of a nice test. You do have to know quite a few terminology things. Like you'll want to know what your sample means and the population parameters. You'll need to know that kind of stuff. But those will show up on the exam, on the practice exam, so make sure you do your practice exam. Probably if you're watching this, you're probably going to do your practice exam because you care about the test. All right, let's look at another one. I'm going to give you this five number summary. That is, let me find this on here on the test. Sorry, it takes a second to find it. Okay, here's this one. It gives me this list of scores, and I'm going to obtain the 5 number summary. I wish I could. I'm just gonna have to write these down. I wish I could write right on here, but I can't do that with this program. I mean, I know I have something that will do that, but I don't have it on me. So we're just gonna do it the long way. Okay, I'm gonna write down these scores. So you can just write these. Well, you might have to write them down because you probably don't print these out. Some of you maybe do. I don't know. 40, 46, 49, 54, 56. This one they put them in order for you, which is nice. 62, 67, 70, 73, 77, 85, 87, 90, 94, and 95. Sometimes my pen does weird things. Okay, so I'm going to look at these. Again, I'm going to count the numbers. 1, 2, 3. So the 5 numbers summary. Really, they're just looking for the median, the upper quartile, the lower quartile, and your highest number and your lowest number. Okay, that's what the 5 number summary is. So my median, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So my median is going to be the 7th number in. 1, 2, 3, 4, 5, 6, 7. So, I think I counted wrong. 1, 2, 3, 4, 5, 6, 7. I think I wrote something down wrong because I am not. Oh, sorry. It'd be the 8th number. So I have 7 on each side. I was like, what am I doing wrong? Okay, so here's my median score. Okay, is 70. Then I count these 1, 2, 3, 4, 5, 6, 7. So I'm going to take my middle number, 3 on each side. So 87, sorry, is my middle number. And that gives me my upper quartile. I do the same thing down here. There should be 7 on each side. I pick my middle number, which is 54. That's my lower. And then, of course, my endpoints are here with my low and here with my high. So what my range is going to look like is 40, my 5 number summary, 54, 70, 87, and 95. Okay, so that's pretty easy, but it's just nice to know what it is. All right, the next one is another, we're going to calculate the tax. This is a tax problem. All right, so the first thing we're going to do, let me show you what the problem looks like here. Okay, Matthew and Don are married, filing jointly with an adjusted gross income of $95,352. This one's pretty straightforward, but let's just run through it just in case. Assuming they have no dependent children and are claiming the standard deduction, calculate their federal income tax for 2013. Okay, and again, that chart is on the table, on the formula sheet. So that's awesome. All right, let me move that out of the way. So there it says what they gave us was their adjusted gross income. So AGI is 95,352. Okay, so make sure when you get that, you can see, here's my list, here it is. Adjusted gross income, we need to find the taxable income, and then we'll figure out the tax tables, minus tax credits if they have them, but I don't think it get listed in any tax credits. So taxable income is going to be our AGI minus deductions minus exemptions. They are married filing jointly. So the first thing we're going to do is their standard deduction. It says they're taking the standard deduction, so that's going to be minus 12,200. Okay, that's the standard deduction. Then they also get one exemption per person. Okay, so there's 2 of them. They don't have any children. There's 2 of them, so we're going to do 3,900 times 2. We can just do it this way, minus 3,900 minus 3,900, right? 1 for each of them. Okay, that should give me my taxable income. So let's calculate that. I can get my calculator. There it goes. Okay, 95,352 minus 12,200 minus 3,900 minus 3,900. Okay, I come up with a total of 75,352. Okay, that's my taxable income. So to find my taxes, I have to use this tax table. And we did some of these in the homework. And remember, so they're filing jointly. And so I'm going to tax the first 17,850 at 10%. Okay, so I'm going to go, and I'm sorry I can't show you that table at the same time I'm writing these down, but I'm going to have 17,850 times 0.1. That's my 10%. It would really be 0.10, but you don't need to write that 0 in. Okay, so I'm going to tax that much at 10%. Then I'm going to find my next section. My next section is going to be taxed at 15%, goes clear up to 72,500. So I'm going to subtract this that I've already taxed at 10% from the 72,500. Okay, so what I'm going to have here, I do parentheses, and I go 72,500 minus 17,850. That number that I calculate there is going to be multiplied by 15%. Then I'm going to do one last thing, which is, because the next bracket goes clear up to into the like to 146. Okay, so I don't have to worry about that. I only have a taxable income of 75. So I'm going to go 75,352 minus this 72,500. Because I don't have to pay, I already paid 15% taxes on those. I don't want to have to pay that again. That's going to be times 25, okay? So now I'm going to just simplify this formula down so you can see this is how I work it out honestly. I always write everything out, okay? I'm going to leave this one as it is, but this I'm going to go ahead and do that math on. I just think you can never be too careful. So I'm a big fan of writing things out and working out the little details, even if you think you can do it in your head. Okay, so my number here that I'm going to be multiplying by 15 is 54,650 times 0.15. Okay. Then I'm also going to do the same thing for that. Oh shoot, I did not mean to open that. Nope, not that either. Sorry, my screen's crowded. It's a lot to do on one little screen. I remember my husband when he's like, you need another screen. I'm like, no, I don't. And now that I have it, I just can't function without it. But anyway, 75,352 minus 72,500. I get 28,52. So not very much of my income is being taxed at that upper level, which is great. 28,52 times 0.25. All right. Now I'm just going to do the math. Get out my calculator, and I go 178. Oh, sorry. 17850 times 0.10, right, or 0.1, plus, this one you don't have to push equal in between, but you can, 54,650 times 0.15, plus 28,52 times 0.25. And I get $10,695.50, and in the taxes you always round to the nearest dollar. So there's my answer, $10,696. Okay, so these take a long time because there's just a lot of steps to them, but just you don't have to. They're not super complicated. They just are lengthy. Okay, this one's pretty easy. but we're going to do it anyway just because we haven't done one of these. I don't think I've done one of these for the class yet either. Maybe I did. I can't remember. Okay. This is a confidence interval. No, I have not done one of these for the class. So in a survey of 774 employees of a large company, 26% said they had job satisfaction. Find a 95% confidence interval for the true population proportion. Okay, to find a 95% confidence interval, I'm going to use my little worksheet right here. I mean my, what is this, formula sheet. And I first am going to find the margin of error. Okay? So the margin of error is 1 divided by the square root of n, which is my number. So in this case, n is 774. Okay? So, my margin of error is 1 over the square root of 774. Okay, let me show you a quick way to do that on your calculator. If you're using a computer calculator or a different one, you can just do 774 square root and then use this flip over button, 1 over x. It's the best. Okay, so then my margin of error is 0.0359. Okay, I'm going to take that number. I'm not done. If it just asks for the margin of error number, you would be done. But in this case, they want to know the confidence interval. So I'm going to actually take my number. Now you see these all the time in polls. They're like, well, the margin of error is this many percent, meaning that if it falls in between these numbers, then it's really the same as if it were any of those numbers, as if it was in the mean. So I take my 26% that said they had high job satisfaction. So I go 0.26, and I'm going to add and subtract my margin of error. So what that looks like on the calculator, there it is. What that looks like on the calculator is, oh, here's my margin of error already up. So I'm just going to add that to 0.26. And I get 0.2959. So remember in this case, that's the upper end of my thing because that's the part that I added. And then I'll finish telling you what I was going to say. But and then I'm going to take my thing again, 0.0359. I'm going to make it negative. I'm going to add it to 0.26. And I get 0.2241. Okay, so that's going down on this end. Okay, so this is my range of, it's my confidence interval. I can be fairly confident that it's 95%. Yeah, I mean, it's 95% confident that it's valid if it falls in there. So, what I was going to tell you is that this is actually going to be a percent, 22.4. This one's going to be 29.6. And you want to make sure that you convert your problem to decimals before you add it. So they told me it was 26%, but remember that your margin of error is not listed as a percent. It's just listed, it really is, you can move it to a percent, but it comes out as a decimal, and so you need to convert this to a decimal to make it work. Okay? All right, that was we're about halfway done. I need to hurry though. I get to go to a maturation program with my daughter today, so that's always super awkward. All right, I was just going to talk about distribution. So there's left skewed, right skewed, and then just symmetric. When we're talking about the distribution, the thing to remember, so there's a skew that looks like this. There's our normal bell curve. And then it can be skewed also like this. What's confusing on this is that this one is called a left skew and this one is called a right skew. Why that is is because like this one to me looks right because all the information, all this big bumps right here on the right. But what this means is that there are outliers to the left that are dragging this line out to the left. Okay, so we're actually looking at the tail, not at the bump when we're talking about if it's which direction it's skewed. So just remember it's kind of the opposite of how it looks, or just make sure that you look at the tail, not at the bump. Okay, so that's the left skewed, right skewed. So that one's easy. Okay, this one is going to take a little bit of time. This is one of the, let me skip up to this one. This one is the distribution with the 68, 95, 99.7. And I'm going to draw it out for you again, even though it takes a little while, because once you do this part, you can just keep it for the rest of the time. Okay, so this just tells me, it gives me the mean and a standard deviation, and then it's asking me a certain score. So I'm going to draw my chart first, and then we'll put those numbers in, okay? So I'm going to just make my distribution. I remember last time I wanted it bigger. Oh, it's because I had giant numbers. Oh well, we'll still make it big. Okay, I should have made it so tall though. All right, the first thing I'm going to have is my mean, okay? It told me that the mean was 2.9. Okay, I don't really need to write that in yet. We just need to get our charts in. So my mean's there, and then I know with my 68, 95, 97, 99.7 rule that this section right here is going to total 68%. So I divide that by 2 and I get 34 here and 34 here. Okay, so that's my 68. Okay, my next standard deviation away from the mean is 95%. Okay, so from here to here is 95%. That's 95, take away 68. So I do 95, take away 68. That equals 27. I divide that in half. So that tells me that there are 13.5 here and 13.5 here. Okay, because they're sharing what's left of that thing. So this total is 95. That looks like 75. 95 right there. Then my next standard deviation away from the mean, and this is not accurate really. This would be down in the slow end, but just pay attention to the lines. All right, the next one is 99.7. So I'm going to do this down here. 99.7 subtract 95. That leaves me with 4.7, right? And then I divide that by 2. Gives me 2.35. Okay, so that's what's in here. Then I have this very last little bit that goes clear to 100, so I'm going to have 100 minus 99.7 gives me 0.3. I divide that by 2 and I get 0.15. That goes right there, and 0.15 goes here. Okay, now I'm ready to do my problem. And again, if you want to do this before the test or right when you sit down to take the test, and you can just save it and use it for all the problems that are like this. All right, so now on my problem, it tells me that 2.9 is my mean and my standard deviation is 0.4, and they want to know a student with a GPA of 2.1. So let me get that. So we have, if my standard deviation is 0.4, then this is going to go to 2.5. I'm going to subtract 0.4 because I'm going negative. And here's my 2.1. And that's all the information I need. I could fill out the rest of this, but I don't need it. They want to know for 2.1. So I'm going to look here. They want to know what percentile would this person be? Well, it's going to be, I'm going to add up my percent scores from 0 to here. Okay, so I get, and you could probably do this in your head, but 0.15 plus 2.35, and I get 2.5. Okay, so they are in the 2.5th percentile. Okay, that's how that works. And so, and always, sometimes it'll say, well, how about a person, what percent of grades fall between the between 2.1 and 2.9, and then you just add those together. So this is a really easy way to do it if you've already got that set up. Did I have another one of those? I don't think I did. Okay. All right, we're going to look at this one. This always yells at me because I try to make it move faster than it wants to move. But come on, people. I got stuff to do, right? All right, if the weights of newborn children in the United States are normally distributed with a mean of 7.5 pounds and a standard deviation of 1.25 pounds, what percent of babies are considered as having low birth weight, less than 5.5 pounds? Okay, use a standard score and percentile on page 390 in your book. All right, that is going to be our z-score chart that is on our formula sheet. If it didn't tell you this, use a standard score and percentile chart, how would you know if this was going to be a standard deviation chart or with the 68, 95, 99.7, or if we're going to use z-scores? They actually tell us kind of the same thing, but you can do the z-scores, like sometimes the numbers don't fall exactly on one of those deviations, and then you don't really know what it is. So that's what the z-score does, is it tells us how to find it when it doesn't fall on a complete, not exactly on a standard deviation. Okay, so let's look at this one. First thing we're going to do is we're going to use we're just going to use this to find our z-score, which we already did before, right? So that was our data value minus the mean divided by standard deviation. So data minus mean, divided by standard deviation. So in this case, the data value is, let me just show you this one. The data value is 5.5. That's what they want to know. They're interested in this birth rate. Okay, is 5.5. So we go, 5.5 is that number. The mean was 7.5, and the standard deviation is 1.25. Okay, so I'm just going to use those numbers. I'm going to go 5.5 minus 7.5 divided by 1.25, and we'll calculate that. Okay, that goes 5.5. Whoops, not 55. 5.5 minus 7.5 equals divided by 1.25. Now remember that was a negative number. Some of you were missing that when I was looking at the discussion, so watch out for that. So my number is negative 1.6. And then I'm going to go to my z-score chart. I'm going to find negative 1.6, which is actually an exact value, and it's 5.48. So, and they rounded it to 5.5. So 5.5 percent of babies are considered to have low birth weight, which is less than 5.5 pounds. Interesting, right? Same percent. Okay. I think I just have okay, a couple more. The next one is this one. I'm just going to kind of talk you through. We're not actually going to do it, but if you were filing your taxes as a single person in the 25th percent tax bracket, you'd be lucky if you were making that much money as a single person, and you qualified for a standard deduction of $6,100, how much would that standard deduction save you in taxes? So in this case, all you're going to do is take that $6,100 and multiply it by 0.25, by 25%, because this is a deduction that comes before taxes, before you apply the tax rate. Okay, so this changes your income, and so this is subject really to the 25%. Okay, I mean, it's not like it's subject, it's getting subtracted from your income, so that's what it saves you. It's going to save you $1,500. Let me show you quickly another example of that, which is 37. Well, on my test it's 37. So if you were filing your taxes as a single person in the 25% tax bracket and you qualified for a tax credit, how much would the tax credit save you? The tax credit, you get all of that back. So that's the difference. The tax deduction is going to, you're only going to get 25% of that off, depending on what tax bracket you're in. But if it's a credit, it comes off at the end after you've already calculated your taxes. So just be aware of the difference between those two problems. Okay, let's look at 31. This one was this is another one is kind of one that is a concept more than calculations, so I want to just go over that with you. A local statistics professor wants to replicate the University of Maryland study that was conducted on the issue of healthy adult body temperatures. So I'll just read it. For many decades, the healthy adult body temperature mean has been assumed to be 98.6. They consider that the null hypothesis. That's like standard, right? That's 0, or that's what we are working from. To focus on an objective benchmark prior to the data gathering. These are kind of complicated words, but I'm not that the words are complicated, but it's not a really super clear problem. Anyway, a significance level of 0.01 is selected for the study. That means less than 1%. That means it has to be less than 1% or less than 1 out of 100, right? The professor finds through her study using a random sample of 100 healthy adult participants that the sample mean was this many, so 98.3. She determines that supposing the null hypothesis to be true, the probability of getting a sample mean or lower is less than 1 in a million. So for all of those words, what you want to look at is what is the probability of getting a sample mean of 98.3. If it's less than this 0.01, then there is enough evidence to assume that the sample mean is going to be lower. Okay, there is enough evidence if it's less than that. Okay, and we don't have to calculate this, luckily. So they're just going to tell you that. So if they're looking for a significance level of 0.01, and then they tell you that the probability is less than 0.01, which it is, it's 0.00001 or something like that. I don't know if I said enough zeros. Then there is enough evidence. Okay, so that's a little confusing. But just look for those two things. You're looking for the significance level, and you're looking to see if the probability is lower than that significance level. And then you can choose that there is enough evidence. And in this case, we just had to look to see, like we were looking at 98.3, which is lower than 98.6. Okay, so hopefully that's helpful. That's kind of a confusing topic. But again, you don't have to do any of the calculations, which is nice. All right, let me find the next one. And I think this might be our last one. Nope, actually we're done. That was all. So the last two things were things I already talked about. So good luck on the exam. Again, the biggest thing you're going to need on this one is just your exam formula sheet and a calculator. You don't need your, whoop, that was weird. You don't need your Excel spreadsheet for this. You will want it for the final. All right. Good luck.